What's up my friends? So in this video we are going to see how we can implement our own catch Linux command using C and also in assembly language. Alright, so let's get started. First thing we are going to see like the behavior of catch command. Okay, for example, let's create a file, for example vi vim, for example I don't know, text dot txt, for example, hello world, like this, save it, clear. And so the catch command, it's like a command that show you what is inside the file or list you the content of this file. Okay, so first thing we do catch, then we do like the name of the file. Okay, so as we can see it lists the content of this file. Okay, so let's see the behavior of this command. So for example, let's do catch without the name of anything. Okay, so it will give us nothing. Okay, for example, let's do cut and a file that it doesn't exist. Okay, so it's to cut the name of the file, no such file or directory. Okay, so we're going to delete this message when we don't find this message in our directory. Okay, so for example, let's do cut and text and also so it's gonna loop on all these files and list them. Okay, now we know like the behavior of this function. Let's start to create by using C language at the first, then we're going to do it in assembly. Okay, so let's do, we have here, I have two version, C version and assembly version. Okay, so let's start with C version. Okay, so C version like this, clear, and let's start. So we're going to do vi main.c. So now our important header files, we have here std input and output like this. Then we are going to need the unistd for write function. Okay, so std unistd.h like this. Okay, so let's create our int main like this. Let's go up here, int main like this. Good. We are going to need the argument counter and argv, int arg, let's say just ac, and here char pointer to pointer av. Okay, good. Now first thing, as we said, let's open another shell like this. Okay, good. Now let's, for example, create a file. I don't know, for example, let's save this file like this and let's open it again. So as we can see, we have our file. Okay, so let's do like this. So we are going to do the name of the program and then the file that we want to open. Okay, so we are going to need the argument vector. So we are going to do before taking the name of the file, we are going to do a test. For example, if the user did not enter the name of the file, here as we can see, it doesn't do anything. Okay, so we're going to, for example, show him a message. Okay, so let's do Ctrl C like this and let's do if condition here. So if the argument counter is equal to what, is equal to 1. Okay, so he entered the name of the program. Okay, so if the AC, which is the argument counter, is equal to 1, then for example we're going to print please enter a file. I hope you see the message because the background it's like this. Okay, and we are going to do like this and return 1 for error. Okay, good. Now in the else condition, okay, if the user entered the name of the file, so first thing we need to do is open this file. So we're going to need to use the open syscall. Alright, so as you can see here, I have a documentation about the open syscall. So the open syscall is used to open or create a file and obtain a file descriptor. Alright, so the file descriptor is just we can say an ID for a file to use like to indicate that this number is for this file. Okay, so this is the syntax of this open syscall. It takes the name of the file then the flags, then the mode. Okay, let's forget the mode right now. We're just going to focus on the flags. The flags, they are just saying what you want to do with this file. For example, just open it, or open it for writing only, or open it for reading and writing, and so on. Okay, now we just want to open to read. Okay, so we're going to do or read only. So the syntax is the name of the syscall, the path, which is the name of the file, so I'm going to take it from the argument vector. Then here we have int flags, so we're going to pass this or read only. Okay, so let's copy it like this, and let's go back to our editor. And don't forget that this syscall is returning the file descriptor. So remember, each file in the system which we open it takes an ID, like to indicate this number for this opened file. Okay, so it will be an integer. Okay, so we're going to do, for example, here, let's say int file descriptor equal to 0. Okay, so comma like this. So if the file descriptor will equal to open like this, and as we said, the argument vector, which is the name of the program. Okay, and to remember, as we said, the cat command can open multiple file one after one. Okay, so what we need to do a while loop. We need to loop on all these files to open them and read this and read the content in these files, and list the content in these files. Okay, so we need a while loop. Okay, we need to loop on all these arguments, expect the name of the program. Okay, so what we are going to do, we need to do a while loop here in the beginning. So we need to do while. Okay, so we need an int I equal to 0, for example, or like this. Good. So for example, let's say 1, because we are going to move the name of the program, so we're going to start from the second argument. So we're going to start, and we're going to do a while loop while the I is less than or equal what, the the argument counter minus 1. So as we can see, now we are going to loop from the I was equal to 1. So we are going to start from the second index. So this is the index 0, index 1, 2, 3, 4, until we reach the last file. Okay, so while I is less than or equal the argument counter minus 1. I guess so we don't need minus 1. Okay, so just like this. Okay, so we're going to open this and close it right here. Good. Now let's continue. Okay, so we're going to do ft file descriptor, and here, as we said, we need the name of the file. Okay, so av argument vector of index I. Okay, then as we said, we need to the flags. Okay, so the flags are just what you want to do with this file. We want just to open it and read it. Okay, so we're going to do or read only. Okay, and for the mode, we will not use it in this video, but just the mode are for when you want to create a file, you need to pass the permissions of this file. That's it. That is the role of the mode last parameter. Okay, so we're going just to do here 0. Okay, good. Now let's continue. So here I guess I'm gonna change the background to see the code. I hope this is good for you guys. Okay, so as we said, we have here the file descriptor is equal to the open syscall, take the file, the name of the file. Okay, then here the flags, we just want to read this file only, and the mode 0 because we want to pass any permission because we are not creating any file. Okay, so here we need to do a check. So as we said, the open syscall return the file descriptor, which is a number, so we need to check if there is an error. Okay, so the error in this syscall is less than 0. So if the fd, the file descriptor, is less than 0, it means it's error. Okay, so if fd less than 0, so we're going to do, for example, print f. Okay, we cannot, this file cannot be. So let's type exactly what the cat command show us when we when, for example, this file is not exist in the directory. Okay, for example, let's do cat gg. So it say cat the name of the file, no such file or directory. Okay, so we're going to copy this like this and remove this. Okay, okay, so we're going to do something like this. Okay, let's make it smaller like this. Okay, good. So here we are going to end this line, okay, like this. So here just an if condition in case the open syscall cannot open this file. Okay, now so let's say we open this file. Now we need to read it. Okay, so what we are going to use, we are going to use the read syscall. Okay, so as you can see here we have a read syscall. So the read system call in C is used to read data from a file or other input source identified by a file descriptor. Okay, so this is like as you can see the syntax of this syscall. It's return SIST type. It take the file descriptor of the opened file, as we said. Then here the buffer where we're going to store what this syscall read. Then we're going to pass the count, like how many bytes or data you wanna read from this file. Okay, I hope it's so easy for you guys. Okay, so let's do like this. Good. So we're going to remove this and create a variable right here. So let's copy the data type like this and paste it right here. Okay, so SIST for example, let's say return bytes, good, equal to 0. So we are going to copy this and like this. Okay, then we need to create a buffer. So char buffer like this. For example, it will take 100. Okay, for example. Okay, good. Top here. Okay, good. So the file descriptor, we say this variable will contain the file descriptor of the opened file. Okay, so we're going to remove this. Then the buffer, we're going to pass our array buffer like this, and the count. So the count will be the size, like how many bytes you want this read syscall to read. Okay, so we're going to pass the size of this buffer. Okay, so we're going to read 100 bytes. Okay, good. Now let's see what's going on here. We have the written bytes, then we just need to type it. Okay, so we're going to use the write syscall. So we're going to do write one the std out. So we want to see what we typed here in the std output. Okay, then the buffer. Okay, then how many bytes we want to read from this buffer, which is 100. Okay, good. Then we're going to do e++ like this. Good. Now let's do our checks. We have a while loop here. We open the file, and we store the file descriptor in this variable. We check, then here we read, and here we write. Okay, then e++ to move to the next file in the argument vector. Good, good. Now let's open, okay, like this, and let's see. Let's save. Okay, now let's do clear and gcc. Alright, we have a problem popping. Okay, did you mean? Alright, so we need this, I guess, this header file, the fcntl.h. Okay, so we're going to copy this for the modes. Okay, for the flags, this second parameter in the OpenSys. Okay, let's save and do clear. Okay, we don't have no problem. For example, let's say we will not pass any parameter. Please enter a file. Okay, so edit out again. For example, let's pass a file that doesn't exist in this directory. For example, let's say gg. Okay, here we have a problem. Okay, so null no such file or directory. Okay, null no such file or directory. For example, let's do it again. Okay, we have a problem here. This is garbage value. Okay, let's do vi main.c. We have here, if the file descriptor we have got, yeah. So here what happened when he find this if condition, he go into this if condition. Then what happened? He goes down here and do this line of code. He is reading the file descriptor, which is an error. It's not a valid file descriptor. So we need to stop right here and start again in the while loop. So we're going to do e++. So let's do like this. sorry, let's do like this, e plus plus and continue. Okay, so like move out to the next argument and do continue, which means we will start the loop from here. You will not continue right here. Okay, so let's do like this and compile again, and let's start from the beginning. For example, there is no file. Good, please enter a file. For example, a file that doesn't exist right here. So cut, there is no such file or directory. Okay, but here, as we can see, he's doing it again. Yeah, he's accessing the null. So here, as we said, we need to do -1, because even we start from 1, we need to do -1, because as we know, he accessed the first file, which is the RR. Okay, and this problem here, as we know, this argument vector is a 2D array. So we have the first array, which is a string, the second array inside the 2D array, which is also a string. But the end of this 2D array, there is a null. And now he is accessing the null and trying to open it. Okay, so the problem again is right here. We need to do -1, like to just end in the last previous element in this 2D array, which is the argument vector. Okay, now let's do again compile, and let's do like this. Okay, there is no such file or directory. So now let's try to cut this main.c. Okay, for example, let's do edit out and main.c. So as we can see, he opened the file and read it and write it, but there is a problem. The file, which is the main.c, is bigger than 100 bytes. So he is like this, he is reading 100 bytes and write it, then move to the next file. And to prove it, we are going to do this. For example, let's open the first file, then also open main.c. So as we can see, he will write until this part, then start again and write until this part. This is the problem. He is just writing 100 bytes, then he is stopping right there. Okay, so let's do again vim main.c, and now let's try to solve this problem. Okay, so what we are going to do here is a while loop. So we are going to do a while loop, and in each while loop we are going to read this amount of bytes, which is 100 bytes. And the if condition will be when this written byte variable is greater than 0, because when, for example, the file has more data, then the written byte will be greater than 0. So we are going to continue this while loop, and we are going to write this written byte. Okay, so we are going to do here write. So we're going to do a while loop like this. I love while loops, I don't know why. Okay, so we're going to copy this line of code, y and p, like this. So like this, and here also. Okay, and here also like this. So we're going to remove this line, and we're going to do an if condition, which is when the result is greater than 0. Then what you are going to do, you are going to read this amount of bytes, not 100 bytes, but this amount of written bytes that this is called return. Good. Now let's see. Okay, let's do gcc, and good. As you can see, he read all the data in this file. Okay, for example, let's do main.c and also main.c and also main.c. Good. 1, 2, 3 and 4. As we can see, we have here 4 main.c, so he looped on them all and write them all. Okay, so this is our program. Let's do another case. For example, edit out, and between these files we are going to insert a file that it is not in this directory. Okay, for example, hh. Okay, so he will open the first file, the second file, and the third file, and he's going to show us a message which is cut no such file or directory. So our program is working well in C. Now we're going to move to assembly. Okay, so now let's open this file like this. So it will be like a documentary for us. So we are going to compare each line of code in this C code and trying to do it in assembly. Okay, I know this is the part that you all waiting for, so let's get started. Okay, so let's do like this and clear here, and let's remove, for example, let's just close this and do like this. So I hope this background is good for you guys to see the code. So cd point and assembly version. Okay, clear vim main.asm. Okay, now the real work. So now let's create our important section. So we have here section dot data like this. Okay, then we're going to need the section dot bss for the buffer. Okay, then here the section dot text and global start like this, then start label. Okay, good. And of course don't forget our done label to end our code. So move rex16, then we have here XORing the the RDI and RDI, then syscall. Good. So in our section.data we need to create these strings. Okay, so for example here there is no such file or directory. For example, please enter a file or something like that. Okay, so first thing we are going to do is missing file. Okay, missing file message. Good. So define byte and please, or let's say cut, there is no file. Okay, good. Then we need to calculate the length of this message. Okay, so we're going to do missing file length. Okay, equal to is equal eq to the actual address minus the first character of that string. Okay, so like this. Okay, then we're going to do, for example, also here there is no such file or directory, so cannot open file message. Okay, like this. Let's just do cannot open message like this. Okay, define byte, no such file or die. Let's just copy it and like this. Okay, good, and like this. Okay, so and then we're going to do a new line. Okay, so like this, there is no such file or directory, and a space before the name of this file that we cannot open. Okay, then cannot open len is equal to eq actual address minus the beginning of this string. Good. Now here in the section .bss we need the buffer where we are going to store the reading or the written data. Okay, so we're going to do reserve byte like this and buffer, for example, 100. Okay, now let's get started. Okay, so first thing we're going to get the argument counter, the argument vector, and so on. Okay, so first thing I'm gonna need the int I to loop on the argument counter, so we're going to do move r10 0. Okay, then what we're going to need also, we need to take the argument counter from the stack. So in a previous video I explained, and I'm going to explain in another video how to take the argument counter and the argument vector in assembly. Okay, so we're going to do move rbx the RSP. Okay, what is inside the RSP? So the RSP in the start label, he is pointing to the argument counter. Okay, so now the RBX is containing the argument counter of this program. Okay, then what we need to do also, we need to load the pointer of the first argument vector, which is the AV of index 1. We don't want the AV of index 0, the argument vector of index 0, which is the name of the program. No, we want this we want the next argument, which is we want the next argument, which is the first file. So we're going to do load. This load is used for pointers when we want to take a pointer from a stack. So we're going to save it in the R12 and the RSP plus 16. Okay, so just to know, the RSP is pointed to the argument counter. RSP plus 8. Why plus 8? Because we are in a 64-bit architecture, and in this architecture each block of memory is containing 8 bytes. So to move to the next block we need to add 8 bytes. So RSP is pointed to argument counter. So the RSP plus 8 is pointing to the first argument, which is the name of the program. So RSP plus 16 is pointed to the second argument, which is the first file, and we're going to load it in the R12. Good. Let's continue. Then what we need to do, we need to compare is the RBX, which is the argument counter, is equal to 1 or not, because if equal to 1, then we need to do this if condition. We need to show this message and return 1 and get out from this program. Okay, so compare is RBX is equal to 1 or not. Jump if equal. The GE is equal to jump if equal. If this condition is true, jump to missing file label. Okay, so we're going to create a label like this. So we're going to go down here like this and print this 2 point, and let's start. Simple thing, just syscall, just the right syscall to print this message, nothing fancy. Okay, so move RX1, move RDI1, move RSI what. So we're going to move this message, missing file message like this, a comma. Then in the move RDX, which is here in the RDX, we need to pass the length of the message that we want to print, which is this variable. Then call our syscall like this. Okay, and the program will execute and continue. Let's test it. Okay, so we're going to do NASM. Alright, we have a problem in the line 9. Let's see. Okay, in the line 9 we have this problem. This should be here. Okay, sorry, buffer like this. Okay, good. Link, for example, let's say we are not going to pass anything. Cut, there is no file. Good. Let's continue. Okay, now, and by the way, when this label done, he will continue to this done label, so the program will execute normally. Okay, good. Let's continue. Okay, so now we need to decrement the RBX. Because what? Because we are starting from the RSP plus 16, from the second argument. Okay, and just because we are starting from 0, so we need to loop until the previous element, because if we go to the last element, which is the argument counter number, the actual number of the argument counter, we're going to face the null pointer, and we won't do this. Okay, so we're going to decrement the RBX. Then we're going to jump to open file label. Okay, let's copy this and like this. Okay, open file label, and in this place is gonna be like the place of functions. Okay, function part. Okay, now let's continue our open file label. So simply this is going to be this while loop, and as we know, have an if condition. Until the R10 is less than the RBX, we are going to continue. So compare RBX with R10. So if equal to each other, then we are going to do jump equal to done. Good. Else we are going to call our OpenSysCall in assembly. So let's see how we can call it in assembly. Okay, let's remove these two tabs like this. Okay, so in OpenSysCall in assembly, the RX take the number of the syscall, then RDI take the pointer to null eliminated, then the RDI take the path of the file, then the RSI take the flags, as we said, if you want just to read or write, and in the case of create you need to add also the RDX, which is the register that take the role of the mode. Okay, if create, you need to pass the permissions for these files. Okay, so we have rex take the number of the syscall, rdi the path of the file, rsi the flags, rdx the mode if you did the create flag. Okay, good, let's continue. So we're going to do like this: move rex to syscall number. We're going to do some comment, open syscall like this. Good. Then we have here move what rdi. Now we need to dereference this artware. So now the artware taking the address of the argument vector of index 1, but we need the pointer to the first character, so we need also to difference this artware. So we're going to do these two brackets, and it's like the referencing the pointer to take the address of the first character in the argv of index 1, or just in the string. Okay, so let's say a comment here, dereferencing the pointer to get the first, to get the string. Okay, good. Now let's continue. Then we're going to do move what rdx, which is take the role of mode. In this case 0 because we are not calling anything. Then our syscall. So as we said, we need to do an if condition if the file descriptor is less than 0. So we're going to do compare what the rx, but the rx is the role, take the role of the syscall number. Yes, but after any syscall or any function, the rx take the role of the return value. So the return value from this function, which is an integer, will be saved in the rx register always. Okay, so compare rx with what, with 0. So jump less. If this rx is less than 0, then we are going to jump to cannot read. Good, let's do here label. Okay, 2 points, and let's see what we are going to do. First thing, we need to print the name of this file. Okay, so we have the name here in the rdi, so it's so simple, but we need the length of this string, so we're going to call strlen. So let's go up here, and here in the functions part, and we're going to call our strlen. We're going to XOR in the rdx like this, and we're going to do a loop label. Okay, so we're going to compare byte. Okay, then we're going to take the rdi, because as we said here, the rdi is taking the string. In the string we have the string is in the rdi register. Okay, plus what, plus the rdx. So the rdx in the first is going to be with 0, so it's going to be like an index. Okay, is it equal to 0 or not, which is a null terminator. If yes, jump equal to done with points here. Okay, this done, we have just return. So return, why I didn't return is gonna like return us to the next instruction. Okay, so here we're going just to increment the rdx and jump to strlen. Good, let's continue. Okay, so here we have in the rdx the length of this string, and we're going to do move rx1, move rdi1 the file descriptor, then also move rsi rdi. So move the string from rdi to rsi. This is a problem here. Okay, so let's just, because the rdi here is set to 1. Okay, so let's just flip them. Okay, so we're going to do like this. Good, let's do here. So the rsi will equal to string in the rdi, then the rdi will is equal to 1, then the rdx is equal to the length. We're just going to do syscall. Okay, then move rx1. Here let's do a comment printing the name of the file, and here print the cannot open file message. Okay, let's continue. Move rx1, move rdi1, and move rsi the message. Okay, there is no such file or directory. Okay, let's type it right here. Then we're going to need the length. Move rdx, cannot open len. Good, let's continue. And our syscall. Good, then we're going to jump where? Jump to the open file. Okay, so as we said, we need to do e++, and I'm going to show you how we're going to do e++ in this case. Okay, to go to the next argument in this argv vector. Okay, first we're going to copy this and jump right here. Let's do like this, remove this e. Okay, so as we said, each argument is saved in an 8-byte block in memory. Okay, and as we said, to move to the next block of memory, we need to add 8. So simply we just need to do here plus r9. Okay, so this r9 is just a variable. Okay, so we're going to do here move r9 equal to what? Equal to 0. Okay, good. So this r9 is gonna be added by 8. So here we are what we are going to do, we are going to do add r9 plus 8 to go to the next argument. Okay, to go to the next argument. So here moving to the next argument. Okay, good. I hope you understand it. And also here, okay, it's the same thing. Okay, so now let's test if the file we cannot open it. Okay, let's do save nazem. Okay, good. I love problems. We have here the first problem in the line 38, label alone on a line without a column. Okay, let's see. In the line 38, yes, we just need a column right here. Good, nazem again. In the line 74, okay, again, let's see. In the line 74 we have this problem, syscall. Yep, we need syscall. Okay, nazem again. In the line 75, good, let's see. In the line 75, add r9 plus 8. What is this? Like this, nazem, good, link, good. For example, a file that it doesn't exist. Yes, we have a problem. Good. Let's see where is the problem by our eyes. Okay, so the first thing, we compare rbx like this, compare rx with 0. If it's less, we cannot read. Okay, then jump to down. Yep, as we can see here, the r10 doesn't increase. So as we can see here, we cannot increase the r10. Okay, so this is the problem. What we need to do after the condition is false, we need to do increment the r10. Okay, let's do again nazem link. Alright, we still have the problem. Good, let's see again. Okay, let's see, we have increment r10. Good, syscall equal. Let's say he cannot open, cannot read, cannot open like this. Okay, and okay, good. Jump to open file, cannot open land, add r9. Alright, now let's use the gdb to see. Okay, so let's do nazem for the last time. Good. For example, there is no files. Okay, good. So gdb, okay, break at the start and run, for example, with this file. Okay, so ni to move. Okay, is he will move to the missing file label? No, because we passed a file. Okay, then decrement the rbx, then open a file, yes, compare the rbx with rh. Rbx is equal to, let's see here, is equal to 1, good, and rh is equal to 0, good, done. Now increase the rh, sorry, then here the open syscall. Yeah, he cannot open this file. This is the, I guess this is the in decimal number is -2, I guess. Okay, then compare the rx, yes, he will jump to cannot open. So call strlen. Alright, let's dive into this call strlen and let's see. First thing, we're ignoring the rdx, then ni, comparing. Okay, this is the problem, I see it. Okay, let's see the problem. Okay, so as we can see here, we said that we are going to do an strlen function. Okay, so in this function we have label. So first thing, we are ignoring the rdx, then going inside this label, which is the loop, and doing this stuff. Then here we are jumping again to the rdx. So the rdx here is like the I. For example, as we know in the C, we do string str of index I. So this rdx is like the I, and the I is always in the in this jump equal to 0. So here it's an infinite loop. We need to jump to this label like this. Okay, so we need to do loop like this. Okay, so Nazem, yep, I have a problem. I need to add a punch before here. Okay, Nazem, link and program, good. Magic file, good. There is no such file or directory, and the name of the file, good. The problem now, it's the work now is gonna be so easy. Okay, let's continue and let's see. Okay, so let's continue. So in this case, now let's see the case when we need to open the file. So in the case when the file we open it. Okay, so what we need to do, we need to call the read syscall. Okay, so let's see what the read syscall need. So as we can see here, the read syscall which need to be loaded into the rx register. So the number of the read syscall is going to be loaded in the rx register, which is 0. Then the rdi will take the file descriptor, as we can see here. Then the rsi will take the buffer, and the rdx will take the bytes to read, then syscall. It's so easy. Okay, let's continue and let's see. Okay, so the problem here, we need to save the file descriptor. So first thing, we need to pass the file descriptor in the rdi register. So move in the rdi register the file descriptor, move in the file descriptor in the rdi register like this. Okay, then we're going to call a function. So we're going to do call read file. So we're going to go in the functions part like this, and we're going to copy the name of the function like this. Okay, and paste it right here. Good. So we're just going to open the file, read the file simply. So we're going to call, let's see what we need to do. We need to call, yep, we need to call. Alright, so here we have our function, and it's gonna be a function with local variables. So we need to use the RBP and the RSP because we need to save the file descriptor, because we are going to do a while loop, and in this while loop we are going to use the write syscall, and the write syscall is using the RDI register where we saved the file description. Okay, so we are going to do push RPP. If you don't know what is this push RPP and the prologue and the epilogue, you can see this video right here. I explained everything about functions, and this video also about local variables. You can see it. Okay, the link in the description. Okay, let's continue. Then we're going to do move the RSP and RPP, making the RPP point where the RSP points. Okay, good. Then subtract the RSP 16, okay, to make a place for the RDI register. Then we are going to create a loop. Okay, so read loop like this. Okay, so now we created the stack frame of our function. So now we need to save the RDI register in the stack. So we're going to do move keyword in the RBP, okay, and the RDI. Okay, now we're going to do our while loop. So move RX0, move RDI, RDI the file descriptor, good. And let's do like this. We're going to move the RBP, okay, because the RDI is gonna change, so we need to fetch the file descriptor from the stack. Okay, that's why we did this function in the first place. Okay, then as we said, move RSI the buffer and move RDX how many bytes we want to read. Okay, then syscall. Okay, good. Then here we're going to do comment read syscall. Okay, read syscall, and here we have open syscall. Okay, sorry, write syscall. Okay, we're going to write what we stored in the buffer. Okay, so have here write syscall. So move RX1, move RDI1, move, as we said, the RDI is gonna change, so that's why we need to save it in the stack. So move RDX 100, then move RSI the buffer and syscall. Good. Now what we need to do, we need here before writing, so here this is the case if there is data in this file. So as we said, the RX is always in any syscall or any function or anything, the RX is the return value. So here we are going to check. Okay, so we're going to compare RX with 0, jump equal where to read done. So we're going to copy this like this and do read done, and we're going to pop, or for example, so then we're going to do subtract the RSP16, no, add to clear the stack, sorry, then pop the RBP and return. Okay, then we're going to continue right here. We need to add R98 as we said to get to the next argument, then jump again to where to the open file. Good. Now let's do another, no problem. Good. For example, a file like this. Alright, this is the problem. As we said, he just read this amount of bytes and stop. So the problem in this part exactly. Okay, so let's start. As we said, first thing, we're pushing the RPP, saving the RDI in this place, taking the RDI from the RPP, yes, and RX equal to 0. Then here we compare the RX and jump equal to read done, else it will type this. Okay, let's do GDB to see. Okay, so we're going to do GDB program, break at the start, run main.asm. okay, then we're going to do ni. Okay, tree, this is the file descriptor, tree in this case. When we open the file, then we're going to go to the function read file. Okay, good. Push RPP. As we can see, we push the RPP. Alright, here the stack frame of the function. Good. Now we save the RDI here in the stack. Good. Here we are calling the read syscall. As you can see, it's with this amount of bytes. Then we're going to compare read done, then we're going to print it. As we can see, yeah, this is the problem. I found it. This is the problem. So here, when this write syscall end, he go automatically to this label. So we need just to do here, jump again to the read loop. Okay, it's like I++ or something like this. Okay, so now we end this. Okay, good. Let's do, for example, 3 files like this. The first, okay, section.data. Then here we have also, okay, now let's test. Okay, for example, main.asm file message. Okay, done. And here we have file message. What is this file message? Move rdx. Okay, we have section.data function part. Okay, let's do vi. Sorry. Okay, let's continue. Let's see. Let's do again. We have here done. Good. Okay, let's do, for example, a file. For example, let's do vi gg.text. For example, anything. Okay, more than 100 bytes. Okay, copy like this. Okay, nazem link, and good, it's working well. For example, this and assembly file. Here is the problem, he is just printing just the first file, so we don't have the while loop. Okay, let's see where is the problem. Okay, so let's track the problem. Okay, so main.asm, let's close this. So first thing, he's opening the file right here. Then he's jumping to call read file. Good, he's jumped to call read file like this, and he's going upstairs here like this, then return. Okay, so he returned here and add r9h, then jump to open file again. So we compare rbx, so r10, and jump equal to done. In this case, no, because we have as we said, 2 parameters. So we increase r10 and open the do the open sys call. But where is the problem? I don't know. Let's do gdb. Okay, gdb dot start and run main.asm. I don't know the second file. Let's copy it. Okay, like this. Let's copy this. Good. Then gdb break start. Okay, let's remove this, and let's continue. Okay, and good, missing file now, and he's going to open the file. File descriptor is 3. Good. He's going to read the file, so now he read it. Good, everything is good. r9 gonna be added to 8. Good, and jump to open file. Okay, so r9 is now by 8. Okay, so compare rbx is equal to what? Is equal to r10 is just equal to 1. Increase r10, sorry. Then we are going to move, so the RDI now is equal to the main.asm. Then why here he cannot open this file? This is the problem. Why the RDI is equal to the file main.asm? Why? Okay, where is the problem? I don't know. main.asm, it's a file that's in our directory. I don't know where is the problem. Okay, let's see. So for example, let's create another file. For example, blah blah. For example, let's fit with anything. Why? Okay, let's do nazem link, and let's do, for example, blah blah, like this. So why there is no such file or directory? I don't know why. I don't know why. Okay, let's see our code. Sorry, main.asm. So here in the open file we have at r9h So I found the problem that was here. I didn't move RSI0, which is the flag that I wanna use in this OpenSys call. So I'm gonna do move RSI0. It's a stupid fault. Alright, let's do Nazem again. Link. Alright, now everything is working well. Now we reference gg.text and blah blah again, and as we can see here our main.asm. okay, everything is working well. Let's for example try just to main.asm. as you can see, good. Okay, now let's test our catch command for the last time. So as we can see, for example, let's try to print them 3 times. As you can see, it's good. It's printing 3 files. For example, let's do another file, for example this file. Good, is working well. And let's try to the real command to compare. So catch gg.text. Alright, as you can see, bb, everything is working well. Good, the same thing. Okay, now let's do for example cut, for example blah blah. Okay, and our command, good, everything is working well. Now for example let's do blah blah, and for example gg.text, for example, and magic file, no such file or directory. For example, let's do a new line. Okay, let's do a new line before this. Let's do, I don't know, for example let's do let's make here in the open file we are going to do move rx1, move rdi1, move rsi uline, move rdx1 syscall. Good, so let's do a new line here. Okay, so new line, define byte 10. Okay, Nazem, link, and like this. Okay, there is no such file or directory. Okay, for example blah blah and magic file and gg. Okay, blah blah, there is no such file or directory, and gg.text. Alright, now this is the end of this video. I hope you enjoyed how you can make your own catch using C and using also assembly. As we can see here, I really enjoyed making this video, and I'm gonna do a playlist, and there's so much command line Linux that we're going to make, ls, echo, touch, a lot of things. Okay, so just be prepared to more video. See you then, peace.